Hello friends, welcome to Unacademy and welcome to today's session. In this session, we are going to discuss about secondary storage device management, especially hard disk, how we can able to store and retrieve data from your secondary storage devices because the secondary devices the data is going to be stored in the form of blocks. Before going into discussion, first of all, let us see our anthem. Crack GATE and ESE, India's largest learning platform, none other than Unacademy. Get Plus subscription, access unlimited live and recorded lectures from India's topmost educators. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's best educators. About myself, Srinivasrao Sir, having more than 15 years of experience in the GATE, especially in the CS stream, having a good industry experience with relevant certificates like DB and Cisco and Red Hat Linux. Throughout my journey of GATE, I taught in many premium academies with a high success rate. Many of my students are alumni of IITs and NITs, and many are working as a software professionals in a topmost positions in topmost MNC company. So, to crack a GATE examination, there is a need of a good stuff is required, good classes required, and good live quizzes required. So to get all these kinds of things, you're going to get only from Unacademy. Use a referral code to get the admission into Unacademy, so that you're going to get a concession up to good amount. You can also do the redeem points also. If you get the admission, then you're going to see that all kinds of restrictions are going to be removed. Then you can freely watch all the classes, and you can attempt live quizzes, discussion forums, and many other whatnot. Whatever is there to get crack your GATE examination, they are all available in Unacademy portal. Unless and until you take the admission, you are going to be restricted access. You cannot able to access all the contents which are there in Unacademy portal. As far as as far as admission concerned, there are two kinds of subscriptions. One is for 12 months, the other one is 24 months. For both the subscription, my referral code is eligible. You can able to get the good discount by using this referral code. Second and third year students can opt for 24-month subscription, and fourth year students can opt for 12-month subscription. The duration of this subscription, you are going to get many kinds of things, not only the classroom sessions. There are discussion forums, discussion sessions, live quizzes, and previous paper discussions. Many are available in this. So why to do late? Immediately you get the admission, use my referral code, and after that I'm going to start my new subject maybe on plus. You may not get on free, of course. So immediately you join, take the admission, use my referral code, and enjoy the benefits which are offering by Unacademy. So if you would like to speak with any kind of a faculty which are there on Unacademy platform, as far as GATE and ESE concerned, just click on this link and you try to fill out your form. Then Unacademy backend people is going to divert your discussion or queries with your corresponding faculty whom you are requested. So let's crack GATE CSE. Use my referral code. Get the admission in Unacademy. Subscribe our YouTube channel for the latest notifications and updates. Hit the bell icon too. So let us start. Let us start. Why there is a requirement of disk allocation methods, also called as file allocation method. So before that, let me explain one important thing. So when I'm talking about hard disk management, your hard disk is having series of smaller blocks. Your data is going to be stored in the form of smaller blocks like this. Before that, you're supposed to split according to partitions. Otherwise, it is going to consider as a single partition system. You can able to do multiple partition system as your Windows and Linux in any kind of operating system is following a hierarchical file system. When you are talking about a hierarchical file system, friends, you see that we are having initially a root partition. From the root partition, you can able to divert it to other kind of subdirectories or subpartition. So here our root partition is the C drive. From there your work is carry forwarding. So from there you can able to contact any kind of directories, because we are using a concept of hierarchical file system which consists of directories and files only. In that you can able to store your files. That means you can able to store your data in the form of file. A file is nothing but consists of a good amount of data, and these files can be segregated into respective directories. As I said that all the operating system are following hierarchical file system. Hierarchical file system in the sense mainly we are having a first of all root folder. From the root folder we are having a subroot folders. From that you are having a what corresponding a directories. From corresponding directories you can able to store your files into the directory. So as far as the Windows operating system, you say that C drive is our root partition. If you are talking about the Windows operating system, and a C drive is your main root partition. As far as a Linux or Unix operating system, your main folder is your slash. When I'm saying that a slash, it is nothing but what? Your root partition only. And your work is going to start from the root partition. There is a folder called mainly root. So your work is going to be carried forward from slash root. So therefore, friends, you observe that as we are using a concept of file system, that is a secondary device management, which is always following a hierarchical file system. So in that, we are going to discuss about a disk. First, let me explain in this session how the disk inside format. So in the next session, we are going to see that what is the disk structure, and how you can able to increase your performance using a disk scheduling algorithms. So today we are going to see that how you can able to store your data in the disk. Your disk is going to consist of consecutive smaller blocks, and these blocks are only the units where you can able to store your information. Please understand. So you assume that your block number is going to start with a 0, and you can go up to 2 power n minus 1. N is nothing but the maximum block. Now exactly in this particular position only your data is going to be stored. So we all know that disk structure when you are talking. So initially we are having the concept of a flatter. Then after that we are going to have a concept of a cylinder. Then after that we are going to have a concept of a tracks. Then after that we are going to see a concept of sectors. And in that sector we are going to store a what? Your exact portion of data. Now here also I'm talking in the same way. What is that? In this particular blocks only your data is going to be stored. So there are every block is going to given a some number like this. In this block your operating system is going to store your info. Now when I am saying a block, please understand when I am saying this is a one block, please see that. Now I am writing in this form. This is your block 1, and this is your block 2, and this is your block 3. Please see. Now in this block only you can able to store your data. Either you can store data or you can store addresses, that is up to you, but it is going to both it is going to provide. It provides data as well as you can also provide store what addresses. It can able to store both of them. Now I'm saying that your block is divided like this and it is going to store your data. I say record 1 and record 2 and record 3 and record 4 and so on. Now you see, whenever user is trying to retrieve some kind of a data, this is completely is in your hard drive only. I am talking your secondary storage device. Now your secondary storage device has got three blocks. Now if a user is here, would like to access the data, he can able to access the data by contacting the respective blocks. So I'm seeing like this and I'm seeing like this. So where are you going to see that how the user can able to give this kind of a request to access the blocks? Very simple. When I say that I entered into C drive, just double click on C drive and you click on the respective folder. When I click on a respective folder, which is nothing but what? In that if you find any file, as and you click this particular file, then immediately it looks this file where it is available. It looks for this file where this particular file is available. Is it available in a block 1 or a block 2 or a block 3? Therefore it is going to do a manual search. This is very important. It is going to do a manual search about this file, where this particular file is available, near to me or longer to me. Near to me in the sense, in the first block itself we are going to get. Longer to in the sense you need to search in all the blocks. Therefore your time complexity is a worst, that is a what? European, where n is nothing but number of blocks are available in your hard drive. So this is I am talking about single level searching. Single level searching in the sense I am having a directly block. In that block your records are stored. So after some time we will see that multi-level searching, multi-level storage, we'll see after some time. Now, in order to store your data in the respective blocks, then there are a few kinds of mechanisms are there. One mechanism is a contiguous, the other mechanism is a non-contiguous. So I hope so you got what is the main concept of secondary device management or the hard drive management. Hard drive management is nothing but entire your hard disk is going to split into smaller blocks in order to store your data, and in this block you can able to store data records or you can able to store index records. Both are possible. So if you are trying to store data and your data is going to be stored like this, you all may be having a doubt, how many blocks I will get? This is very important question. How many blocks I can able to get? So please understand this depends upon your hard drive capacity. When I'm saying my hard drive is something like 1 terabyte, and you need to say that what is your block size also. So if I'm saying my block size is something like a 1 kilobyte, therefore what is going to happen, you will come to know that how many blocks are there. So I can say that the number of blocks are in your hard drive. Please understand, number of blocks are there in your hard drive is nothing but what? 2 power 40 it is divided by your power 10. So we are going to have these many blocks. These many blocks in the sense you are going to store your data. This particular blocks only. Your block is going to store your data. Now, sometime he may also ask you how many blocks a file require. This is about how many blocks you will get in a hard drive. Please understand. This question is telling you that how many blocks are there in your hard drive. It depends upon your hard drive capacity and your block capacity. Now, sometime we may also get this kind of a doubt. What is that? How many blocks? Many blocks a file can have? So this is simply can say your file size divided by record size. So when I'm saying your file size divided by record size, then you will understand that how many blocks you require in order to store your particular file. Therefore, if I know that some kind of a blocks I got, for example, 4 blocks I got, And now the system is going to allocate 4 blocks to you to represent your data, and those blocks are allocated to you only, so that your file is going to be referred only within these 4 blocks only, if you consider that. And how are you going to get? You are going to get file size divided by your record size, and you are going to see that the number of blocks which are available. So based on that information, the first variety of a technique called contiguous management. So what is a contiguous management? Contiguous is nothing but the availability of the free space is supposed to be one particular order. For example, you see there's a block 0 and there's a block 1, block 2 and block 3. Now if I am using contiguous allocation, I'm saying that I'm going to start here. So there is a file X, and this X is associated with 0, and this X is associated with 1, and this X is associated with 2, and this X is associated with 3. Please understand carefully. That means here there is a requirement that file X, which requires 4 blocks, and those blocks are contiguously available here, then therefore I could able to assign the memory for them. This is very important. I already say that how many blocks you required for a file X. That's nothing but what? How many blocks you required for a file X. I gave you one important equation. What is that equation? You see that what is the file size? Total file size divided by, you see that your record size which you can able to store your particular block. That means what? What is the size of the record in your particular block? If you know that, then I could able to say that how many blocks I require. So as far as my example concerned, I am taking a 4 blocks the file X required. So I have got allocated immediately all the 4 blocks here because I have got them in a contiguous manner. So this is how. So what is the requirement is, you need to tell you two important things. So whenever you store an entry, so I am filling the entry, filing entry in file allocation table. Understand friends carefully. So whenever you start recording or searching a file, immediately it is going to create an entry in file allocation table. FAT stands for file allocation table. It maintains the record information of all your particular blocks. So therefore, I am accessing a file X. First it will ask you name of file. So the name of file is X. Then it will ask you what is your starting block, exactly where you are going to start your information. As far as the previous slide concerned, you are going to locate exactly at a 0. Therefore block 0 I started, and immediately it will ask you how many blocks, and the ending block it will ask you. So you can say that ending a block, or you can also say that number of blocks you. So I say I need almost all 4. Then immediately it starts searching before storing your data. First it is going to see that you are asking from B0. Then do I have consecutive free blocks available or not for this? As you are asking for 4, then you say that. So B0 is freely available, B1 is freely available, this is freely available, this is freely available. After searching for the free space, then file X is got allocated from B0 and B1 and B2 and B3. This is the permanent storage unless and until you delete it. Therefore, what happened? After allocation of your file X, these 4 are allocated to you. Others must not able to access. This is very important. So these are the few information you're supposed to know. What is that? There is a need of single contiguous set of blocks allocated to this file at the time of what? Creation. We'll ask you what is the name of your file, and what is the starting block for your file, and how many blocks you require to store this information. I already said use this equation. This equation will tell you that how many blocks your file required. So it is require pre-allocation strategy. Why pre-allocation strategy? Before allocation of your data, it is going to check that whether all your blocks are freely available or not available. So in your file allocation table, you're supposed to record an entry. So your file allocation table, FAT stands for file allocation table. You need to maintain your entry records. You need to write every entry, which consists of what? File name, starting of the block, how many blocks you required. These are the three information you're supposed to store in order to do what? Contiguous. When we talk about the contiguous is one of the best example of what? Array. Because array is nothing but linear. When you are saying that linear accessing, you are going to see that address of 0, then you are going to see that address of 1. Immediately next item is available in address of 2. This is how you see that contiguous manner, especially array. In the same way, we are also going to see that disk addresses define linear ordering, and it also supports what? Variable size portions. What are the advantages? Are the very fast access with the contiguous allocation, because you know that all the blocks are contiguously available. For example, I say file X, this is what I am interested. So initially the file X is stored in a block 0, and therefore I need 4 blocks. Immediately these 4 blocks are reserved for you. Therefore, friends, you see that when I am trying to search the information from file X, first it touches B0, and immediately you know that the next addresses are available immediately one after another in a continuous fashion. So that's why very fast, easy to access and very fast access. And good performance because of what? Contiguous allocation of blocks. It supports sequential access as well as what? Direct access. Able to just go and touch the block and try to retrieve what? Data. It doesn't require any kind of what previous block help. This is what is the meaning of what you can also get what? Direct access. But there is a problem. What is the problem? You know that. For example, you see, I have got a situation like this: block 0, block 1, and block 2, and block 3. So this block is see, I have got block 4, and this block is fine, it's available. Now it asks me enter your file name. This is the first requirement. Enter file name, because I need to write this information in a file allocation table, which consists of series of a request what the user is asking for insertion, deletion, as well as searching. I say enter file name. I said that my file name is X. Then immediately it will put the second question, the starting block. So it is automatically done. I am telling you as an example. Starting block, I said that B0. Then immediately it will ask you that how many blocks you require, number of blocks you require. As far as the previous calculation, I understand that there is a need of what? 4 blocks. When I say 4 blocks, then the file allocation table takes that entry, and the file allocation manager FAM, it try to scan your disk that whether you have got 4 blocks consecutively from V0. So we understand this is available, this is available. As this is not contiguously available, therefore your request is denied, and you say that you cannot start with a what? V0 by asking a 4 blocks of what? A request. Then immediately need to change what? A block. It is going to tell you that it's not available. This kind of a system is called as what? External fragmentation. This external fragmentation, even I have a free space, but I cannot able to accommodate the file X. I have got 4 blocks, but I cannot able to accommodate a file X because I need consecutively what? 4 blocks. This is one of the problem, especially in contiguous storage. So it suffers from external fragmentation. So you want to avoid external fragmentation. There is a need of what? Compaction. The compaction, friends, please observe that grid structure. B0 and B1 and B2 and B3, please understand, and B4 and one more B5. I said this block is busy. When you are saying this block is busy and I need 4 consecutive blocks from B0, B naught is your starting, and I need 4 consecutive blocks. As far as that, it is not possible. Why it is not possible? If you start from here, you got only 2. If you start from here, you got only 3, but you need 4 consecutive blocks. Therefore, friends, you cannot able to assign this. That's why instead of avoiding external fragmentation, here 5 blocks are external fragmented. This is not possible, not possible, not possible, not possible, not possible. Just I kept them idle, even though your request has come to you. Therefore, how to avoid your external fragmentation? Very simple. Use a compaction. What the compaction? Make busy partition move towards upper side or lower side. So I can move either side. For example, if I move it back side, lower side I am bringing. So this will come here, and finally this will come here, and finally this will go there. So after compaction, your disk structure is being changed like this. So you got 5 consecutive blocks, and one is a busy block. That busy block is this one only, as shifted to down. This is a busy. Now we got 5 consecutive blocks. Therefore, I can able to keep file X in all the 4 consecutive required blocks. This is what is the meaning of what? Compaction to eliminate external fragmentation. But it is a very costly technique to bringing down the busy partition from what particular position to move either towards to top side or bottom side. And the second one is this is another point, pre-allocation. So you need to do it before only. Once you start the action, you cannot able to do any kind of alterations. Another very important. I cannot able to add a further. Once you start do what process starts. So therefore it is what completely free allocation based. So initially you need to do this point. What is that? What is your file name? What is your starting block? And how many blocks you require? That's why increasing the file size is not always possible. Please understand this example. As far as the previous example concerned, my file name is X, and immediately it will ask you number of blocks you need. Number of blocks I said that 4. Why you got 4? You know, because your file size divided by your record size. Your file size divided by the record size. Using that equation, we assumed that there are 4 blocks that are sufficient for me. And after some time, I added many more lines to that my file. Therefore, what is happened? Your file size is what increased. When your file size is increased, what will happen? Let us see. So it immediately allocated to me 4 blocks. That starts with a B0, ends with a B3. Now from B4, it is given to other file. This is given to X file as you requested initially. After that, I did some adjustment. What is that? Your file size is increased. When your file size is increased, you know blocks are also going to be what? Increased. Then, but I am using contiguous concept. Therefore, the contiguously the space must be available even you increase the blocks or file size. But you observe this is given to already Y file. Therefore, friends, what happened? If you try to increase the file, it will say that it is not possible to store or it is not possible to save because you requested only 4 blocks. It's already allocated to you. And as you are increasing your blocks and file size and the next blocks are not freely available, therefore your request cannot be done. That's why you will get a saving error. Please see, sometime you all may get a saving error because of this. What is that? Almost all the next immediate pre-partitions are allocated to some other file. You're asking by adding a more content into that and you're trying to save. When you are trying to save, immediately it sees that those blocks are sufficient to you or you want more blocks. If you want more blocks, then automatically it checks that contiguously available or not. If not contiguously available, then immediately says that I cannot able to save your file because you are accessing out of a block. So this problem can be avoided, especially in, I mean to say, linked list fashion. Now, next kind of a file system is called as what? Linked list fashion. Before that, we will see the contiguous allocation diagram. There is a file name called count. This is my first file name. The starting block is 0 and number of blocks it requires to length 2. So it sees that, okay, fine. So red color 0 is allocated and 1 is freely available. Therefore, you can give it. This is for count file. The red color indication count. Now second file came. What is that file name, friends? That is tr. The starting block number 14 and it requires 3. Can I able to allocate or not? We will just move on to 14th block. So 14th block available. So we start giving 3 blocks. Its length is 3 now. You know how to get length. I already tell you file size divided by record size. You are going to get a length how many number of blocks you require. So this is given to tr. Now you are asking a mail. So mail, third record is a mail. Starting block is 19 and requires 6 blocks. So we move to 19 and you see that 6 blocks are freely available or not. Yes, freely available. Then immediately start allocation of your 6 blocks. Therefore, your records are being stored exactly in this block only, as these blocks are only dedicated to that particular file. And next we got one more file that is called a list. So when you are saying a list which is starting from 28 and it requires 4. So 28, it starts from 28, it requires 4. So 28 it started and it got 4 blocks here. So one block and the second block and the third block and the fourth block. So that's it, friend. This is how your data is going to be stored. And the last file is a F, which is starting at 6 and it requires 2. So 6 and it requires 2. So 1 and 2. Now we understand what I mean to say external fragmentation. What is external fragmentation? If, please understand, TR needs 2 more blocks. If TR needs 2 more blocks, is it possible? Is it possible? Then we will say no. Why no? Because TR is starting at 14 and it already occupied up to 16. Please understand. TR file is starting at 14. It occupied 15. It also occupied 16. You're asking 2 more blocks. Is it possible or not? So this is freely available. This is freely available. Yes, it is possible. Now if I am asking 3 blocks, so if I ask instead of 2, if I am asking 3 blocks, then problem come. So 3 more blocks I am asking. So 3 more blocks in the sense 17 okay and 18 okay, but 19 not possible. Why 19 not possible? Because 19 is already allocated to a next file that is called what? Mail. In that case, 2 blocks means you can able to get sanction immediately 2 are available, but 3 means it is not difficult. This is what is the concept of contiguous allocation of space. So you want to make this one to possible, you use a compaction, bring all the busy partitions to either towards to lower side or up. Now we have second varieties of file system that is called a non-contiguous allocation. So when you are talking about the non-contiguous allocation, here the disk blocks may not be available in uniformly. The system, the operating system is can able to scatter all your data which are belongs to secondary memory anywhere wherever that is a space is available. That's why it is also called as what? Random. You can also call it as what? Random access or heap access. What is the meaning of random access, friends? We see that there is a disk file which consists a group of blocks like this. Let us say 8 blocks are available in your disk. So here already some blocks are allocated. So we will allocate assumption. This is busy and this is busy and this is busy and this is busy. Now you see there is a request from the file. So file X requesting, please understand. file X requesting I need 4 blocks. Can I able to allocate? So can I able to allocate using contiguous? It is not possible. Why it is not possible? Please understand that because your memory is not contiguously available here. But it is possible with the what random access. That means friends, please understand. I can able to load your file X here, your file X here, your file X here, your file X here. Therefore, it need not be a contiguous. That's what the meaning of what random storing. Random storing means wherever there is a block space is available, immediately the record is going to be spread across that. So advantage is that there is no concept of what fragmentation here. Wherever there is a block of free space is available, the record can able to what stored. But you need to maintain a concept called a pointer. This is very important. What is a pointer? Initially the pointer is a 0. Please understand. This is your record pointer. Initially record pointer is 0. Now that pointer we are going to maintain here. How? Please see that I am writing a link pointer now. We need to maintain a link pointer as this is called as a linked allocation. That means every block is going to link with the other blocks. How? First block 0 we started. So block 0 we started, and after that it is going to link to block 2. So immediately it provides the link to block 2. Then after that it is going to provide the link to block 4 because it belongs to file X. Then after that block 5 and block 6 are not belongs to us, and block 7 it's going to write that this is how, and block 7 to ending nothing is there, therefore I can write about null pointer. Whenever you see that null pointer, then complete file is scanned. I need not go to other blocks. This is how you can see that where to start the searching and where to end the searching. In contiguous, what is going to happen? Where to start the searching and where to end the searching. That depends on contiguous manner only. If I know the file size, if I know the length, I could able to say that where to start and where to end. But in linked allocation, I cannot say that where to end because I am not saying the length. I am saying that how many blocks you need. So I am saying here, so 4 blocks I need immediately. If there is a space, immediately 4 are allocated to you. So you need to write that pointers like this. The last block pointer is supposed to be what? Null. When a scanning reaches to null, then it is going to see that the file is completely scanned. Advantage is this is only what is that? A fragmentation is completely eliminated. We need not bother. A space is available. We can store it. It can be a non-contiguous or random order. But what is the disadvantage? Slow access. Why slow access? After scanning B0, you need to search or go to the B2 using a link pointer. From there, you need to go to B4 using a link pointer. From there, you are going to what? 7. So here also you need to give a file allocation table entry. That entry consists of what is the file name, and that entry also will tell you that this is how many blocks you require. Where is the starting block? And from there, if I know the starting block, please understand. If I know the starting block, and I need not know about ending block because I know that ending block is nothing but end with a what? Pointer. This is very important. Therefore, friends, the allocation is based on individual block, and each block contains a what pointer to the next block in the chain form, and the file allocation table contains a pointer to the first and the last block of files. The disk blocks may be scattered anywhere on the disk. So I can increase the file as well as, please see that I can able to increase the file because it need not be a contiguous fashion. If there is a free space available block is there, immediately null pointer will be removed. That is going to be linked to other block, and the last block is going to what? Having a null pointer. You see that. For example, B0 given to me, B1 given to me, B10 given to me, B3 is given to me. This is initially. And after that I grown my file size. Growing a file size is nothing but what? I am creating a what? With a new content. So many more images came or many more lines of code came. Therefore, you need to add one more. So I am doing adding now. Adding of block. It is a fine. You can able to add the block because it can be what? Non-contiguous fashion. I say said that B8 is added newly, no problem. So what is happening here? Earlier your link pointer is this. Now this will cancel this pointer and give a link to this. Now this pointer is having a what? A link pointer. So link pointer is going to be updated in your particular file allocation table. This is how they are going to be what? You can able to increase what? File sizes. What are the advantages? No external fragmentation. So you need not use any kind of a what? Compaction techniques, and free allocation is not required. Initially, you need not do such a kind of long process. Based on your request, you can able to ask the system if free blocks are available, immediately allocate. Otherwise, they are not going to allocate to you. But many drawbacks are there. What are the many drawbacks? It needs to maintain a link pointer. Please understand. You need to maintain a what? A link pointer. This is the first drawback. And the second drawback, if link fails, this is very important. If link fails, bus, then no data access. You cannot access because it is non-contiguous. We don't know that where the matter is available. So that link only will take you that the chain where to go, where not to go. But if link fails, then you cannot able to access this. So these two are major drawbacks in this. That the files are accessed sequentially only. Why sequentially? First linked block, then it is going to give addresses to the next blocks. It cannot able to access randomly. Middle block data you cannot access. You want to access middle block data, the previous address you need, the previous address you need. So it is having a overhead by maintaining a what? Link pointer. So if link pointer fails, then you cannot able to get the data. So sometimes suffers from what? Internal fragmentation. Why internal fragmentation? The last block, that's what very important. The last block may be having a what? Some kind of a what? Small wastage. So that is called as what? Internal fragmentation. Why you know? For example, my file size is a 512 MB, assume, and my record size is only 100 MB only. Therefore, how many blocks you got? 6 blocks you got. In the last block, you are going to store only 12 MB only. Remaining 88 MB is going to be what? Internal fragmentation. What is the concept of fragmentation, especially in the last block? And you need to have a space for the what? Pointers. So this is how, friends, I'm maintaining it. There is a file. So if I'm saying that my file name is X, it starts at 9 and which ends at 25. Then immediately you're going to have a loop inside as many you want. How the loop inside? First, I'm starting at 9. First, it is starting at block 9. This is the number is given. It can be randomly available. It need not be a contiguous what? Slots. So first, I'm checking in B9. So B9 has got a link to 16. Therefore, immediately this is going to search in block 16. After taking the data from block 16, then block 16 has got a link to block 1. Please understand. From there we move to block 1. There is a link to block 1. So now I will access the block 1 now. So in the block 1 again I will see that whether it is having a end pointer or is it pointing to anybody. From block 1 it is going to block 10. So I am writing a pointer here that 10 is the next link. Then immediately you are going to block 10. So I need to see whether it is having a null pointer or it is suffering to it is providing a link to others. So from block 10 it is telling that block 25. So I need to write a link that block 25 is supposed to go there. So I went to the block 25. Again I am searching for null pointer. Yes, block 25 is given a null pointer which is nothing but a -1, or you can also say that what? Null. So when you say null, you have to stop your work because you reach to what? End of the disk. So how many block access you did from starting B9? So this is one block and two blocks access, three block access, four block access and five block access. So it is allocated to you what? 5 blocks. So if any pointer is missed, then you cannot able to trace out the data because it's a completely what based on chaining. So in order to avoid these problems, so first we have seen contiguous concept. Then the second one we are having non-contiguous concept. Non-contiguous is a passed on links and a contiguous is a passed on array. Now I said that need to maintain it is a complex structure. Why it is a complex structure? Please understand this is easy structure. Why easy structure? Because the blocks are consecutively available to me, therefore I can directly access the content. But it is a complex structure. Why complex structure? Every block you're supposed to maintain a what? Links. So I need to identify these links along with your data. So it is a complex structure because your blocks are having a two important information. One is it is having a links information. The other one it is having your direct data information. So it is having a data as well as it also maintains what? Links information also. So this problem is being eliminated in index based structure. What is index based structure? All the link pointers are brought to one certain position. We don't have internal links. Only one link, all the blocks are supposed to target to that particular block only. Therefore, that's the concept of what? Index based. What is index based? Observe this thing. Block 0, block 1, block 2, block 3, and block 4, block 5, block 6, and block 7. Observe friends. So they are freely available initially, no data is stored. There are 8 blocks are there which starts with 0. This is your secondary storage device. It stores your data in the form of blocks as I told you. Now see, instead of maintaining internal pointers, I want to use the benefits of linked allocation, but I want to avoid the concept of what? Maintaining internal links. I want to go for only one link, not the internal links only. So what I am going to do, I will identify one of the block. I say block 8. I am identifying this block is a what? Is a root to all your file blocks, data blocks. So this I am calling it as a what? Indexed blocks only. Now I am separating links and I am separating data. But in the previous example is not like that. Need to have a link as well as you need to have a data inside. But I am separating links separately, data separate. Now what is going to happen? This is a file X. It is linking there. Please understand. It is also for file X. It is linking there. It is for file X. It is linking there. It is for file X. It is linking there. See that? Now I need not maintain a what? A uniform links from one particular block to other particular block and see that the last block is going to have a null pointer. Now I am not having that kind of information. So what I am having? All the pointers are come to B8 only. Now B8 is the, what I mean is a searching route for you. B8 is a searching route for you as we are designated as what? All the links are here only. Those links are called as a what? Indexed links. Now the B8 consists indexed links in order. This is very important. The indexed file maintains records always in a what? Sorted order only, ascending order. First block 0. Then after that block 1. Then after that block 5. Then after that block 7. But you need not maintain any internal pointers over there. Therefore, you are clearly legible to write your data information. Don't worry about what? Your links. Links are being taken care by your index only. So, your index consists of what? Your linking information, how your blocks are going to be linked to what? Others. So, for B0, after that it goes to B1, B1, B5 and B7 bus. So, this kind of headache is taken care by indexing concept. Now, we see in your hard drive, we have two varieties of blocks. One are data blocks, one are indexed blocks. I am not going to combine index information in your data information like a previous method. I am trying to separate now. Your data blocks are separate and indexed blocks are separate. Your data block consists only data. Your index block consists only information about indexes only index. Therefore, what is going to happen? It is not at all a complex structure because I separated some of the blocks only meant for what? Indexes, like your textbook indices. So some of the pages are indexes and remaining pages are what? Data indexes. So you want to search, first we search an index only in your textbook. If that particular information is available, then we go to data. Otherwise, we are not going to data. So the index file is the base for us in order to search any kind of information. Advantage is superb. As you are not mixing data and index together, links together, I am separating links from your data. But what is the problem? Yes, there is a problem. What is that? If index block is corrupted, bus, everything is gone. What is that? If B8 got corrupted, now I cannot able to get the data because all your data blocks are reliable on your index only. If I lost index block, then I cannot able to get your data. This is one of the drawback of your what? Index structure. Anyhow, apart from that drawback, we are using right now indexed block structure only, not a non-contiguous, not a contiguous. So what is indexed block? Let us see. When you are talking indexed allocation, there is a need of separate block for indexes for separate file. This is very important. There is a file X which requires few data blocks, which also requires few index block. This is very important. There is a file Y, there is a need of few data blocks and there is a need of few index blocks. Every file is associated with data blocks as well as index blocks, as your index block is a fast access of your data as it is following a what? Binary search. Therefore, friends, you need to allocate a few blocks especially for and exclusively for indexes. This is one of the drawback. What is the drawback? Space wastage. Because in your textbook, if you understand that if there are 1,000 pages, around 20 to 25 pages we are going to waste only for what? Indexes only. That's why among the total space you need to separate some of the blocks only for what? Indexes, and remaining you can make use of what? Data. This is the one drawback. So therefore, friends, where are we going to search initially? We are going to search in initially index only. The index is take caring us. It is going to give you the chaining to you from where to where you need to search it. So it is called as a single level index. Now file allocation table contains a separate one level index, nothing but single level index, which consists of what? What are the data blocks which are associated against to that file, and your index entries are what? Always in ascending order only. So what are the advantages? Bringing all the pointers together into one location, that is called indexed block. There is no external fragmentation here. Easy to create file. You can access your file directly as well as what? Sequentially, because we are not depending on data file, because your searching depends on what? Index only. So index is going to give you the routes to your data block where to search and where not to search. But disadvantage is mainly two. One is if index block is lost, what is the problem? And you need to separate a space for indexed block also. That's what. So overhead due to space for indexed blocks is number one. Then number two, if the particular indexed block is lost, then it is going to what? You cannot able to trace the file. And another one is very important. Now I will tell you, see. Data size is equal to 100 bytes and your file size is equal to 512 bytes. Therefore, friends, I can say that how many blocks you need. So number of blocks I need 5.92. This is purely for what? Data. Now see, again, this is for index file size. File size I can say like this, something 512 bytes, and your index size is always lesser than your data size only. I say 10 bytes. So how many blocks I need? So I can confirm that number of blocks I need something like a 51.2. So I can allocate a 51.2 blocks for storing what you access. Or sometime you also will get like this. If I am saying block size is equal to reverse, I am coming 512 bytes, and your data record size, please observe, your data record size is 100 bytes. You may also get like this. Now I am saying how many blocks you need. So number of blocks I need now 512 bytes divided by 100. So I need 5 blocks now. So if you get information like this, you can also solve information like this using. So same case, instead of a data record size, it will ask you that index record size. So take your data block divided by index size you keep. Will say that how many indexed blocks you require. So this is how about indexed allocation. So we have taken the 19th block only for exclusively to index, and this 19th block is indexed block only to your file only to your file X, not to somebody else. So every file is require one index block and the rest of your data blocks. So it may be one or it may be more indexed blocks, depends on entry size, depends on record size. So the above index which I am talking about, when I say index, it is single level only. It is single level index. It's not a multi-level index. So multi-level indexing I want. What is the multi-level index I want? Please see. Now I am going for multi-level storing. When you are asking multi-level storing, please understand your blocks of your hard drive may consist what? Data, or some of the blocks, please understand, some blocks may consist data and some block may consist of what? Address. This address I can say that what? Index. So therefore your blocks are being divided into, if I am using a multi-level storages, if I am saying multi-level structure to store your data, therefore I need to see that from your hard drive, as there are many blocks are available like this, need to be very careful such that some blocks are going to store data and some blocks are going to store addresses. Please understand, some blocks are storing to data and some blocks are trying to store what? So this kind of a system, you see, it's very similar to indexing structure only, but I am expanding it. You want to say the expansion. This multi-level structure is useful whenever you have a large file systems. So when you are having a large file system, then there is a requirement of what? Multi-level structure like this. So in multi-level structure, the advantage is that the particular wastage of space is going to be reduced in this. How? Let us say. So if you are asking multi-level structure, there is a famous architecture called in-core node. In-core node. So this is extension to index file system. The one important point. It's mainly used in Unix and Linux. It is a Unix and a Linux. Windows is as usually using indexed file system only, no doubt. We are using a right now in Windows. If you guess that, what is the file system we are following? We are following FAT, and we are also following what? NTFS, new technology file system or file allocation table 32. We are taking 32-bit. Now both are based on indexing only. Like the previous indexing plus data we are doing nowadays with the Windows, but Linux is completely based on your inode. Whenever you have a large file system, then it is going to use the concept of what? So when I say inode structure is like this. What is that? Some are storing a data and some are storing a what? Addresses, data block address, DBA. So we are going to learn two important elements. When you are talking inode, two important elements we are going to learn. One is the data bytes. Another is data block address. And the other one, we have other terminology, block size, disk block. These are the three important terminologies are required in order to deal with your. So what is inode implementation? So inode is a control structure that contains the key information needed by your operating system. Every file requires one inode, but multiple files also can able to link with your inode, but every file is going to managed by one inode. That is the best structure, one inode to one particular file. So now you see what is the inode structure. Inode structure is like this. We have direct blocks. What these direct blocks have? We have indirect blocks. Two varieties of blocks are there here. Direct blocks and indirect blocks. When you are talking a direct blocks, it is going to store data. Simple answer. It store data. When you are talking about indirect blocks, which stores initially addresses, stores addresses of disk blocks, addresses of disk block. Then that in that address we are going to store what? Exact address of you where the data is going to be loaded, DB. So therefore friends, this is directly storing your data, DB. But it is going to store what? Initially it is going to store DBA. In that DBA we are going to get the address locations to your disk blocks. So we got address location, the disk blocks. In that blocks we are going to store exact data. Please understand. This is what is the meaning of what? Direct. Indirect means what? First level we store addresses which are referencing to original data blocks. This is your first level and this is your second level. But when I am talking about direct blocks, you are having only one level only. Only one level. And in this indirect blocks, we have two varieties. One is single indirect and the other one is double indirect. In exam, you will ask up to 4. The other one is triple indirect. The other one is quaternary. So what is the meaning of single indirect, double indirect, triple indirect, quaternary indirect? Let me write like this. If I am talking a single indirect, please understand. Single indirect means what? Only one level indexing, which means first you store DBA. In that DBA, I'm going to store what? Data, which stands for data bytes. If I am asking double indirect, please understand. Double indirect means what? You will know now. First, I will store addresses of another blocks which are also storing addresses only. In that, I am going to store your data. You see. So this is one level. This is another level. This is what? Your direct. This is single indirect. This is double indirect. Please understand. All three are there. If I am saying direct, the direct consists of what? Direct data only. Now double indirect consists of what? Direct, single indirect, and this is your double indirect. Now if I am saying triple indirect, first initially we store the addresses DBA, which further consist address locations to other blocks which holds the addresses only, and it is also directs to the blocks which consist of only addresses. After that we are going to store what? Direct. This is your direct, single indirect, double indirect. This is your triple indirect. Okay friends, so this is how your structure is being expanded. You will see that somewhere at the last level you are going to check your data. What is the question he will ask you in the exam? Very important question. Every year you are going to expect a question on this. What is the maximum file size? What is the maximum file size? The maximum file size is nothing but your disk block size divided by your block address size, and you say that maximum pointer and store your data. This is your maximum file size, also called as a what? Total file size, how much I can have. For example, I say triple indirect. I am saying when I am saying triple indirect, please understand the maximum it can support, it can have direct, it can have single indirect, it can have double indirect. Please understand. So what is the meaning of that? Finally, triple indirect. So I am covering double indirect as well as single indirect as well as double indirect. My highest level is what? Triple only. So therefore, I will say that my maximum pointer is a triple there. So therefore, friends, you see that your how many addresses you can able to store into triple indirect, and just to store your, this is a maximum file you can able to store. So in some blocks data will store, some blocks address will store. So we have direct data, single indirect data, double indirect data, triple indirect data. So these are the attributes which are there in your inode structure. Who is the file owner? What is the type of the file you are accessing? What's the file access permissions? Means read, write, execute. This is a text file or image file or audio file or video file. That's the type of file. And who is the owner? Who is the group owner? Who is the other user? We have permissions now, 777 permissions. These are the permissions and the number of times the file accessed and number of links and the size of the file. So this is the structure. So direct means you are having data. Indirect means what? You are having addresses, in that we are storing data. Double indirect means what? Address which further stores address, and finally you are going to store what? Data. So these are the important things. What is that? How many blocks you can able to store information? So based on this and total size of the file system, you can able to find it, taking the maximum link. So use the maximum link, multiply with your database size. So for example, see friends, he said that 300 GB disk, 8 direct blocks. So we able to store 8 direct blocks. That means 8 into direct data. What is the data size? And next, one indirect block. And the next one double indirect. Okay friends, now you see your block size up to 128 bytes I can able to store. This is your data. And disk block address size, nothing but index size only 8 bytes. So each disk can contain how many addresses you can keep? How many addresses I can keep in the sense? So in a particular DB disk block, I can able to store 128 bytes divided by, and what is your address size? 8 byte address size. 8 byte address. So you're going to store 16 address locations. That means you can refer to 16 blocks. He is asking what is the maximum possible file size in this. So friends, observe this. First, I have direct. In direct, you can store up to 128 bytes, no data. No doubt, 128 bytes of data you can store in a disk block. When I am talking about single indirect, in the sense, first we will store DBAs, database addresses, disk block addresses. Otherwise, how many disk block addresses you can store? 16. These 16 are being segregated into 16 pointers because it can refer to 16 block locations. This is a 1 dB and this is another dB and this is another dB. Likewise, it is pointing to 16 blocks as far as given information concerned. And if I am talking a double indirect, so we have dBA and that dBA again further to dBA and again it is pointing to 16 disk blocks. This also point to 16 disk blocks which consist addresses and which consist addresses of them. This is the architecture. At last you are going to store what? Your data exactly in this particular disk block. He is asking what is the maximum file size. You can write here. Please understand. 128 bytes I can write plus I'm writing total file size I'm writing. How much it can occupy. Directly I can store 128 bytes. Indirectly 16. In that 16 each block I can store 128 bytes plus, and this is 16 and every block we are having a further 16 addresses. That means 16 square into 128. This is your total file system it can support according to this given structure. What is the maximum file size? The maximum file size is nothing but highest level only. What is your highest level? Double indirect is the highest level as per as previous question. Double indirect, one double indirect pointer. Therefore, your maximum is this only. What is that? 16 and maximum pointer is 2 into your disk block size is 128 bytes. Please understand, I said double indirect pointer covers single indirect pointer and single indirect pointer covers direct indirect pointer. So your maximum file size depends upon your maximum pointer only, degree maximum pointer. So this is your maximum. 16 is nothing but we got the 16 like this. How you got the 16? Your dB size divided by your address size. Then you are going to see that how many addresses you can able to locate it. That's it friends. This is how you can see that inode structure which is useful for large storable things. The one very important point I said that if you ask total file system summation, you do only summation. What is that? Direct plus single indirect plus double indirect. Every time you multiply with your dB, every time you multiply with dB, every time you multiply with dB. First, if you ask maximum, what are you going to do? Your dB by dBA, and you take a maximum pointer, as I am saying here, maximum pointer double and multiply with your dB. This is your maximum answer. Friends, we learn in today's session what are the file allocation methods or disk block allocation methods in order to insert, delete, search your data from your hard drive. So three models we learned: contiguous, non-contiguous, and indexed based. But nowadays we are using Unix operating system that is called in-core node, inode structure. Okay, friends. So in the next session, we see that what is a plateau, what is a track, what is a sector, and how much file size you can store. And in order to increase your disk efficiency, there are different disk scheduling algorithms are there that we will learn in next session. Stay tuned to Unacademy. If you not yet get any admission, please immediately take the admission. Tomorrow our schedule is 2 p.m. to 3 p.m. disk scheduling algorithm and disk structure, YouTube. And on special class evening, that is at 6 p.m., we have questionnaire on your file system. So don't miss file system questionnaire exactly on Unacademy student learning app from 6 p.m. This is about tomorrow's schedule. And day after tomorrow, we are going to have a quiz on entire operating system, complete operating system. So there are around 50 very important questions in the 10-hour theory, and the remaining all are problematic questions only. 50 very important questions. If you're able to solve them, then you're going to crack at least 90% of the marks in your operating system. Timing, we are conducting 2 p.m. to 4 p.m. or 5 p.m. It is available on special class as well as it is available on YouTube. You can access them. Thank you very much.